I'm online already. Wait. Good evening.
Hi guys. Glad to see you here. Hope you enjoy the talk. My name is Priit. He's Nikita. We're here from Estonia and here to tell you about memory leaks. Memory leaks in Java applications. A bit of background of what memory leaks are, a bit more of how to easily troubleshoot and detect them, and finally how to solve them. For the purpose of this talk, let's pretend that I'm a project manager. I'm a project manager who is worried, as they often are, worried that his application should be performed better, and I will turn to Nikita for help, for hints, and see. Hopefully, he'll be able to help me. So, Nikita, now my development team develops a Java application, a Spring pet clinic application, actually. And lately, the end users have started to complain that sometimes the application gets slow, really slow. Sometimes it crashes even. When I ask the operations, they say that restarts help. Then the application runs fast again for a while. They also tell me that they saw some out-of-memory errors in the logs and forwarded them to my developers. When I ask the developers, they say that they looked at the errors, tried to trace the reasons for the problems, but didn't get anywhere, didn't find anything useful in the logs. Maybe based on these symptoms, can you give me some hints or tell me what to do next? I'm stuck really.
Well, if we talk about out-of-memory errors, then the first thing to consider is your application efficient enough? Because one of the reasons for out-of-memory errors can be that your application tries to process too much data simultaneously and your JVM heap is not large enough. That's a very common reason. Mm-hmm. And some data structures are very inefficient memory-wise. But if we take a performance degradation into account, then combined out-of-memory error and performance degradation lead me to a suggestion that you can have a memory leak in your application.
A memory leak?
Memory leak. You see, when your application is being used by end users, there are some objects that are being created during an application lifetime. Well, Java application consists of objects, tons of objects. And those objects are being created, are being used, hopefully, and then they are being discarded. But sometimes, due to application bug, or your developer bug, or your third-party library bug, some objects that are not needed anymore, your application will not use them anymore, but they are left in the system, in the JVM. And a couple of objects here and there, that's not a big problem. It's a waste, sure, but not a big deal. But if that code, that component that leaves those objects are executed again and again, then with time, those wasted objects accumulate and accumulate, their size grows larger and larger, then we have a memory leak situation, when your memory is being wasted.
That sounds logical. So what you're telling me is that I should go to the developers, tell them to find objects in their source code that they don't need, and to destroy, get rid of them, right?
Yeah, sure, if that would be that easy. The main problem with memory leaks is that it's a very common problem, but there is no common working solution. And I can say that. I have struggled with them for years. Mainly you have two options how to solve memory leaks. One of them being memory dumps. You can take memory dump from your running JVM and then analyze it with, parse it and analyze it with some memory analyzer, for example, EclipseMat. But that is sometimes very difficult. To get a memory dump of the server with 16 gigabytes of heap or 32 gigabytes of heap from the production to your developer machine is a big deal. It's really complicated. And to parse that huge dump and analyze that and found what the reason of memory leak in that huge data amount is really complicated. And another solution, or would-be solution, are profilers and different monitoring tools. And the problem with them, first of all, is overhead. Because most of the profilers that we have found on the market make your application from 5 to 100 times slower. Can you afford that?
Not really.
I think so. And the second problem with profilers and such is that they give you tons of information from inside your JVM. They have lots of graphs, lots of data, lots of dashboards, bells and whistles. You have to have an expertise and previous experience to dig something useful out from that vast amount of data. So that's really, really, really hard. Average developer can spend anywhere from a couple of days to a month digging through that information.
So let me get this straight. Memory leaks are a big problem.
Yes.
They affect end user experience. You need to restart the server, etc. And there is no good way to actually solve them.
Not so far. Yes. So far there isn't.
So what should we do then?
Well, you have come to me, and I have the solution. And that solution being Plumbr, of course. And now I shall show it to you. In a nutshell, Plumbr is a Java agent. What does it mean is that you take your application and you put one line into your startup script or application server configuration. It's Java agent Plumbr jar. So you attach Plumbr jar, Plumbr agent to your application, and then you start the application with Plumbr.
And that's it? Now Plumbr is attached? It will tell me what is leaking?
And well, yes and no. No means that one of the common mistakes that developers do when they are searching for performance problem in general and memory leaks in particular is that they underuse the application. In order to find performance problem and in order to find memory leak, you have to use your application at least as heavily as your users do. And to click through the application by hand, it's of course not an option. If you have thousands of users out there in production who are using your application, you can't emulate that by hand. So we have a bunch of JMeter load tests here that can click through application. And that application, I will show it to you, is a slightly modified pet clinic. It's, well, quite simple application, as you can see. And our JMeter test now clicks through that application. And let me show you what's going on inside that application. When I start JConsole and attach JConsole to our application and look at the memory usage, what we can see, this line here, you see that, displays memory consumption of your application. How much memory is being used right now. And it goes up and down because garbage collector sometimes kicks in and clears as much waste as it can. But what we can already see here is that the trend line is up. Our memory usage steadily increases. It goes up and down, but it goes upstairs. Which can hint that you have memory leak, but maybe not. Let us see if Plumbr will be able to find one. And what's now is going on inside is Plumbr is monitoring your application, your JVM in fact, and all applications that are deployed in that JVM, alongside with application server itself and all third-party libraries. and it tries to distinguish between what is normal for this particular application and what is abnormal. Which objects behave differently and suspiciously. It monitors object creations, object destroy, object life, object age, and many more parameters, and try to deduce what is a leak and if there is one. Really try to eliminate a false positive. So if Plumbr tell you have a heap leak, then you can be sure you really has one. Maybe you don't know that already, but you have. So we have to wait a little bit, depending on your application usage, depending on your tests, depending on leak speed. It can take from a couple of minutes to a couple of hours, or maybe a day if you have a particular slow leak, but it will tell you eventually if you have a leak. So you have to wait a little bit.
So what we need to do is attach it to the application
Yes.
server, then use the application,
Yes.
either manually or with load tests,
Yes.
and then wait for Plumbr results. Can we also use it in production then?
Yes, we have a pretty low overhead, not very low, but overhead in about 20%. So you can have that in production, at least in some production environments. You can use that in your testing environment. We do support all major JVMs, Oracle Hotspot, JRocket JVM, IBM JVM. We do support version 5, 6, and 7. And all Mac OS, Linux, Windows, and Solaris. So you can use that in your testing, staging, or production environment. Well, we almost here. Just wait a little bit longer. And as you see, you have really uptrend. We have a leak in that application. We just have to know where it is.
So when you created Plumbr, how did you know?
Sorry,
oh, okay.
we have a report.
More interesting. Let's see what
let me open it. So when Plumbr detects that you have a memory leak, it will show you a report which is similar to this one. First of all, it will tell you how much memory is already wasted in your application, how much memory these particular leaks that we have just found occupy in your heap. Right here we see that almost a third of your heap is already wasted, and it cannot be reclaimed by garbage collector because that's a leak. You still hold on those objects. We have a name of leaking class, being image entry. We have 448 objects, instances of that class already leaked. And now come the sweetest part. Plumbr will tell you down to the class and method and line of code where those leaking objects were created. And next, it will tell you where the objects are now, why they're still alive, because they are accumulated in some linked list, which is held in the field named last used images in the class leaking interceptor. If developer receives that report and opens leaking interceptor class, we see here we have last used images list, really, and on the line 27, these objects are created and put into that list on every request to our application. So that list is not constrained by size in any way. That list has no eviction strategy, so objects are being added to that list and they stay there forever, which constitutes a memory leak. An obvious one, but still. And now when we have this information, we have to fix a memory leak. And in this case, in this particular case, it's quite simple. I just make some simple modification, and I will just constrain that list by size. So whenever we have more than 10 elements in that list, we will remove the most old one. So that particular fix is not quite thread safe, but well, it will do for now. And then we shut down the application. We built the new version of our pet clinic. And we should really verify if this fixes, does this fix a leak or not. Application is built. I start our application again. Wait for it to start and deploy. And now we have couple of seconds. Started. I run my JMeter tests again. Go to my JConsole. Remember this picture, please. And now I connect to my hopefully fixed application, and let us see what's going on here. Hopefully we have your problem fixed by now, but let us see.
So while we wait, I was trying to ask before. Tell me, when you created Plumbr, how did you pick these specific parameters that describe a leak? Or how do you know what to look for?
That's a really interesting question. We created a simple algorithm from the beginning, and then we tested it on many different applications for many different users. I don't like this uptrend, but okay.
Another leak.
And we have a huge set of those memory snapshots, almost 400,000 of them. And we have trained Plumbr using machine learning algorithm based on those different applications. And we have tweaked and tuned our algorithm. So now it finds almost all memory leaks there are. We have 90% plus memory leaks found, if I'm not mistaken. Percent, yeah. Almost every memory leak there are, Plumbr will find that. So, and here we have picture which is much nicer than it was. That memory usage line is confined, and well, we have no problem. The problem is solved.
Looks good, thanks. One more problem that we have. Sometimes when we develop the application, we build new versions of it. When we redeploy the application, we also get out-of-memory errors, just like that.
Yeah, that's another problem. It's out-of-memory in permanent generation, so-called Classloader Leak. It's totally different kind of memory leak, but let us try if Plumbr will find that as well. I will emulate a redeploy. Well, not emulate, it's really a redeploy of our pet clinic application in JT container. And let us wait a little bit and see if Plumbr will spot some fishy here.
There was a pop-up before that announced memory leak.
Yes.
How does that work on a server?
Perfectly. Plumbr is meant to be run on server environment, in production or test environment. The report that it creates is written to HTML file to your hard disk. By default, it will send an email to you as well, so you will not miss the memory leak report. If you run your application in development machine, in desktop environment, then you have those pop-ups and you have those tray icons. And now we have a report stating that your application has a Classloader leak, which leaks about 2,000 classes on every redeploy. On every redeploy, you lost 2,000 classes in your permanent generation. And these classes are held by this class loader, and this class loader is being held by JDBC driver class, which is registered in Java SQL driver manager. And if we look at this JDBC driver, what's the matter? Then we see that JDBC driver when this class is loaded, then it registers itself with Java SQL driver manager. So driver manager has a reference to this instance of JDBC driver. Instance has a reference to a class, and class has a reference to a class loader. So these class loader are being held by driver manager, so a garbage collector cannot throw it away and reclaim, and we have Classloader leak. So we have solved 2 of your problems right now. That's a very good day for me.
Sounds really easy, or I don't know, maybe we've practiced to talk too much. So how can we try it? What should I tell my developers?
Your developers should go to Plumbr EU website. Okay, there is no internet here. Oh, Plumbr EU site, I have it here. What a coincidence. You just type in your email and press the try it button. It's free, in a sense. If you have no problems, and you will not have tomorrow because all your problems are already solved. If you have no problems, if you have no memory leaks in your application, then Plumbr costs you nothing, absolutely nothing, 0. And if Plumbr finds a memory leak in your application, it will provide you part of the report, this part of the report, this part, for free. What's
Sounds
funny?
Good.
Free is a good word. Yeah? Plumbr will provide this information for you for free. So if your memory leak is too small to bother, again, no pain, no gain. Oops. And that information with details, that unfortunately for you guys is paid only. But you can always make a custom deal, so contact us.
Well, yeah, anyway, I heard that it costs around 2 hours of developers' work, so...
Less.
I heard that you were listening. Do you have some questions yourself? I believe there are mics here. If you want to ask something, just shoot.
No questions?
There are 2 hands there.
How about leaks in native memory? Can you find leaks in native memory as well?
Can Plumbr find leaks?
Question was, can Plumbr find leaks in native memory? Unfortunately, no. It's just for JVM code for now, so no C code, no low level. But in theory, it will work with every JVM-based language. Scala, Clojure, JRuby, Groovy, but no native code, sorry.
Good question. Anything else?
No? Then we have a booth over there. Tomorrow there will be a bar. We have Estonian drinks for you, Estonian shots, so come by and taste. And ask your questions if you try to ask right away. And we have 6 more minutes, so we just pass here. If you have questions, then come here and ask. Do you have anything to add?
Thanks for the attention. Come by our booth. Thank you.